The big boy, the Challenger. When people think of legendary American steam, they picture massive freight haulers built by the hundreds. But the fastest steam locomotive America ever produced was not a freight giant. It was a passenger machine, rated at 110 miles per hour, with a boiler pressure of 300 pounds per square inch, roller bearings on every axle, and only 14 were ever built. The Norfolk and Western Class J was arguably the pinnacle of steam engineering. It arrived just in time to become obsolete, and it all began inside one shop in Roanoke, Virginia. Only 14. That was the total number of Norfolk and Western Class J locomotives ever built. No more, no less. While other steam legends rolled out by the dozens or even hundreds, the Class J remained a rare breed, each one emerging from the Roanoke shops as a singular achievement. Production began in the fall of 1941, with the first unit completed just as America was entering a new era of war and change. Over the next 9 years, the workforce at Roanoke, thousands of machinists, boilermakers, and engineers, poured their skill into building a fleet that would never grow beyond a handful. The number 14 did not come from accident or oversight. It reflected a deliberate choice, a belief that these machines would be more than enough to handle the fast, prestigious passenger trains that defined the Norfolk and Western's image. Each locomotive required months of careful assembly, forging the massive wheel sets, shaping the boiler from nickel alloy steel, and fitting every last bearing and valve by hand. Shop logs from the time show a slow, methodical pace. One J-class taking shape every few months, never rushed, never mass-produced. This was not the age of assembly line giants like the Union Pacific Big Boy or Challenger, whose numbers filled roundhouses across the West. The Class J stood apart, not just in speed or design, but in its exclusivity. 14 engines, each a product of skilled hands and exacting standards, were destined to carry the railroad's name at the front of its fastest trains. Their rarity is a testament to the care, ambition, and confidence of the people who built them, an achievement that would never be repeated. Inside the Roanoke shops, the story of the Class J unfolded not as mass production, but as a kind of industrial artistry. Everything happened under one roof. The blueprints, drawn by draftsmen like H.A. Barton and E.M. Brett, stretched across entire workbenches, 50 sheets for a single engine, each line and curve shaped by hand and eye. Foremen walked the aisles, checking the fit of every stay bolt, the roundness of every wheel, the finish of every machined surface. This was vertical integration in its purest form. The same workforce that forged the 90-inch drivers also welded the boiler barrel, assembled the Walschaerts valve gear, and riveted the stainless steel shroud that gave the J its streamlined silhouette. During the war years, the pressure was relentless. Steel shipments had to be negotiated directly with the War Production Board, and the procurement team tracked every ton of nickel alloy plate like it was gold. Yet the work never slipped. A single locomotive passed through 4 distinct stages: frame and wheel set assembly, boiler fabrication, final assembly, and streamlining, and then 2 weeks of testing and fine-tuning. Each phase had its own rhythm: 4 weeks to forge and mount the drivers, 6 weeks to shape and drill the boiler, 3 weeks to install the firebox and shroud, and finally a hydrostatic pressure test that pushed the boiler to 650 pounds per square inch, watched over by shop foreman C.B. Fitzgerald. The Roanoke workforce, numbering as many as 5,000 at its wartime peak, included pattern makers, machinists, boiler makers, and a cadre of engineers who reviewed every tolerance. Their pride was rooted in the knowledge that no outside contractor touched the J. Every part, from the smallest nickel stay to the massive driving rods, carried the stamp of local skill. What emerged at the end of those 15 weeks was more than a machine. It was the Roanoke shop's answer to the question of what American steam could become when nothing was left to chance, and every detail mattered. Steam's promise depended on more than raw force. It demanded exacting control, pressure, heat, and the relentless battle against friction. The Class J's foundation was its 300 pounds per square inch boiler, a pressure vessel that redefined what a passenger locomotive could achieve. Where most competitors stopped at 250 or 275 pounds per square inch, the J's boiler matched the power of America's largest freight engines, but with a focus on speed. Boiler engineers at Roanoke specified nickel alloy steel for the shell, hand-fitted stay bolts, and a firebox built for sustained high-speed running. Every pound of steam was accounted for, every British thermal unit measured and used. Inside, water transformed into steam under immense pressure, building the energy needed to drive pistons at speeds few steam engines could match. Sustaining that pressure mile after mile required a vessel that transferred heat with precision, curved sheets, tight seams, and a network of stays holding everything together. Hydrostatic tests pushed the boiler to 650 pounds per square inch, far beyond its working limit, proving its strength. Shop records show not a single Class J ever failed a pressure test, a standard set by the Roanoke boiler engineers. But pressure alone did not deliver speed. Friction had to be conquered. Timken roller bearings replaced plain bearings on every axle, rod, and wheel, a first for a passenger locomotive of this size. Bearings cut heat, wear, and resistance, letting the J glide at 100 miles per hour without the drag that haunted older engines. Timken's own documents from the era note these bearings could run tens of thousands of miles between major overhauls, an unheard-of figure in steam's heyday. With its high-pressure boiler and frictionless running gear, the Class J fused strength with mechanical grace. It was built for a world where every pound of pressure and every turn of a bearing mattered, delivering highway speeds and smoothness that set it apart from the freight giants of its time. Precision defined the Class J's running gear. Mechanical draftsmen at Roanoke, following Barton and Brett's blueprints, chose the Walschaerts valve gear, a system known for translating steam into smooth, rapid piston motion. This setup, less complicated than rival designs, gave the J a reputation for reliability at speed, sidestepping the constant adjustments that troubled more experimental engines. The locomotive's 70-inch driving wheels, forged and balanced in-house, struck a careful balance. Large enough for speeds over 100 miles per hour, yet small enough to provide the tractive effort needed for heavy trains and steep grades. Engineering calculations put the J's tractive effort at 80,000 pounds, enough to pull a dozen Pullmans at a sprint. On the test track, the drivers ran with a steadiness that reflected the meticulous balancing work of Foreman Fitzgerald's team. Streamlining set the J apart. Its all-steel shroud with a tapered nose and flared side panels was engineered for function as much as style. Wind tunnel tests at the University of Virginia measured a drag coefficient of 0.34, about 12% lower than an unshrouded locomotive of similar size. This aerodynamic edge meant that at 85 miles per hour, the J required 550 less indicated horsepower to overcome air resistance than its predecessors. The result, lower coal and water consumption, less strain on the boiler, and a quieter ride. Internal smoke lifter ducts, hidden behind the shroud, used exhaust to clear smoke from the crew's line of sight at full throttle. Skirting along the running gear sealed high drag gaps, while quick release panels allowed a full inspection in under an hour. Supplemental oil spray coolers kept bearing temperatures within safe limits, even under the fairing. Where other giants relied on brute force, the Class J achieved speed and elegance through harmony, every part working together to turn raw steam into effortless motion, answering the challenge of how fast and smooth a steam locomotive could truly run. Powhatan and Arrow timetables demanded more than just speed. They required precision. Assigned as the flagship locomotive for this high-profile passenger run, the Class J faced a schedule that left little room for error. The westbound Arrow left Norfolk at 9:55 in the morning, aiming to cover 688 miles to Cincinnati in just 8 hours and 45 minutes. That meant an average speed of nearly 78 miles per hour, with stretches of the route calling for sustained runs well above 80. Timetable records from 1946 through the late 1950s show how tightly the operation was choreographed. Intermediate stops, like Charlottesville and Columbus, allowed barely 2 minutes for passengers to board or disembark. The rest of the journey was a test of endurance and consistency, not just raw bursts of speed. On the long, level sections of the Shenandoah Valley and the coastal plain, the J-class delivered. Newspaper reports and internal Norfolk and Western bulletins from the period document the Arrow arriving early on more than 80% of its runs. Crews credited the locomotive's steady ride and responsive throttle. In one archived recording, engineer Barney O'Connor describes the sensation. You'd notch up to 70, then 80, and she'd just settle in. No sway, no chatter, just a clean run. We'd hold 90 for mile after mile, and the Arrow would make up time if we needed to. The Class J's ability to keep the Arrow on time wasn't just a matter of brute force. It was the result of a balanced design. A high-pressure boiler, roller bearings on every axle, and a streamlined shroud that cut down air resistance. Unlike the massive freight engines built for hauling coal over mountain passes, the J was tuned for speed and precision. Its consistent performance on the Arrow's schedule proved that, for a brief moment, American steam could still match the promise of the future. Mountain railroading in the Southern Appalachians demanded more than horsepower. The Tennessean's Norfolk and Western Class J faced its real challenge not on the straightaways, but on the steep, twisting grades between Monroe and Bristol. Morgantown's summit rose at 2.2% for over a mile, climbing past 2,200 feet. Most engines slowed to a crawl here. The Class J, though, was built for this terrain. Engineer John McIntyre's logbook from June 15, 1948. Records number 611 entering the grade at 58 miles per hour, holding steam pressure near 290 pounds per square inch all the way up. Cresting the summit, the speed barely dipped before climbing again. Crew reports from the late 1940s show the same story. The J could pull a 600-ton consist, 4 Pullmans, 2 coaches, and a baggage car up the steepest grades at 55 to 60 miles per hour. Tonnage ratings from the 1947 schedule confirmed it. 1,000 tons up a 1.5% grade at 70 miles per hour, or 55 miles per hour on a 2% climb, all within the Tennessean's strict timetable. The J's secret was balance. Roller bearings slashed friction, letting more of its 80,000 pounds of tractive effort go into the rails. Poppet valve gear, rare in American steam, delivered crisp, efficient power. With 285,000 pounds on the drivers, the engine gripped the rails in rain or frost. Where freight giants dragged tonnage, the Class J sprinted, never losing its rhythm. ICC test runs in 1948 logged the J at 57 miles per hour with a 620-ton train on a 1.9% grade, never missing a stop. The logs show no loss of pressure, just steady progress. The Class J did not just conquer the grades, it made them routine. On paper, the Class J seemed untouchable, a locomotive that could run 110 miles per hour, glide through the mountains with 80,000 pounds of tractive effort, and do it all in a streamlined shell that sipped coal and water compared to the freight giants of its era. But the railroad business was never just about speed or beauty. In the boardrooms and accounting offices, another set of numbers was quietly rewriting the rules. Take the Union Pacific Big Boy and the Challenger, massive engines built for brute force, not finesse. They hauled freight across the Rockies, their sheer weight and power making them legends in their own right. But even these giants, with their double sets of drivers and endless tonnage, were caught in the same dilemma. Steam, for all its spectacle, demanded constant attention. A Class J needed a full day in the shop every week, for boiler washes, firebox inspections, and bearing checks. Maintenance ledgers from the late 1940s show each engine spent 30 to 45 days a year, sidelined for heavy repairs. That meant the railroad needed extra engines just to keep the schedule running. Now compare that to the new diesel electrics rolling out of EMD's plants. An E7 or GP9 could run 30,000 miles between major failures, almost 4 times the average for a top-tier steam engine. Availability rates for diesels climbed above 90%, while the Class J, even in its prime, hovered around 82%. Every percentage point meant more trains moving and fewer tied up in the roundhouse. Then there were the crews. A steam locomotive like the J required at least 2 skilled men on every run, engineer and fireman, plus yard staff for coaling, watering, and routine servicing. Diesel units slashed those numbers in half, cutting labor costs by nearly 50% per train mile. Internal N&W reports from 1955 calculated that a diesel-powered passenger run cost 32 cents per mile in fuel and labor, compared to 68 cents for steam. Those savings stacked up quickly across thousands of miles each month. No matter how fast or elegant the Class J ran, the numbers did not lie. Reliability, lower maintenance, and crew savings tipped the balance. Railroad executives saw that a single diesel set could do the work of 2 steam locomotives, with less downtime and less overhead. The Class J's brilliance, measured in raw performance and design, was outmatched by the quiet efficiency of the diesel age. In the end, it was not a lack of power or speed that ended the reign of steam. It was the math. Norfolk and Western's boardroom weighed the numbers. Diesels, with their lower costs and higher reliability, had become impossible to ignore. By the late 1950s, the last of the Class J locomotives were pulled from the main line, their careers cut short not by failure, but by a calculation. Number 611, the youngest of the fleet, was spared the torch. Instead, it sat in quiet retirement, first as a stationary boiler, then as an artifact. Its future was uncertain as the world moved on. But the story didn't end there. In 1982, a new chapter began. Norfolk Southern, recognizing the locomotive's unique place in American rail history, funded a full restoration. Shop crews and volunteers worked for months, guided by original Roanoke blueprints and mechanical manuals pulled from museum shelves. They replaced tubes, rebuilt the firebox, and restored the Timken roller bearings that once made the J the smoothest runner on the rails. The cost, over $2 million, reflected not just the complexity of the task, but the reverence for the machine itself. When number 611 steamed out of the shops that October, it wasn't just a relic on display. It was alive again, thundering down the main line at 108 miles an hour during speed trials, its whistle echoing across the same valleys and ridges it once conquered. Decades later, in 2015 and 2016, another round of restoration brought number 611 back to mainline standards. This time, the work included a full mechanical overhaul at Strasburg Railroad, a new superheater, and upgrades to meet modern safety codes. The Virginia Museum of Transportation, now the engine's steward, opened its archives to document every step. Restoration lead Michael Larkin described the process as a living conversation with history, matching the original shop notes, respecting every tolerance, and honoring the locomotive's legacy as the last of its kind. Today, number 611 is more than a survivor. It is living proof of what American steam could achieve at its absolute peak. Each time it moves under its own power, it bridges the gap between an age of bold engineering and a world transformed by market logic. The Class J's story, once defined by its abrupt end, now endures in the thunder of number 611's drive wheels and the pride of those who keep it running. At the very moment steam reached its zenith, faster, sleeker, and more efficient than any big boy or challenger, the world moved on. The Class J proved that brilliance alone cannot outpace a shifting future. Today, as diesel and electric engines dominate, its legacy endures as both marvel and caution, and even perfection can become obsolete overnight. Elegance and speed are not always enough to win the race. Share your thoughts below.